Check one. Check one. Right. Good evening, everybody. Today, the plan is to do power and energy. That is unit number 10. Today is one session. We can finish at least about 65 to 75 percentage of power and energy today, which means a small section will be there remaining for us to do next week as well. So today is day one session of power and energy of electrical appliances. Before we start, confirm me from your end. Can you all hear me properly and see the board clearly? Yes, 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 perfect. Right. There's a small issue in live streaming. That's why I got a bit late. YouTube live, there was a small issue. Now live is going on, right? Hari, Henang will start the session. I gave you all the tute already. Now for the physical students, I have already given the printed tute. As this is a free link, anyone can join. I have sent the tute to the website as well. I have sent the tute to the WhatsApp as well. So tute is there in WhatsApp as well. Power and energy of electrical appliances. This is your unit number 10. Simple lesson, but guaranteed you will get questions from this lesson. Guaranteed you will get questions from this lesson in your final exam. Hurry. Hurry. Right. Right. Power and energy. Power and energy of electric electric appliances. That's your unit number 10. Unit 10. Now, power and energy. This power and energy, you all already learned in grade 10. But the power and energy you learned in grade 10 is mechanical power and mechanical energy. Mechanical power and mechanical energy you learned in grade 10. Here, we'll be learning about power and energy connected with electrical appliances. Lamai, what are electrical appliances? What are electrical appliances? Appliances that work with electrical energy. electrical appliances. So in those electrical appliances, there will be a certain power, there will be a certain energy consumption. So we are going to learn about those things in this lesson. As we are talking about electric appliances, as we are talking about electric appliances, tell me some electric appliances in your houses. Tell me some electric appliances that you have in your house. Give me a second, I'll allow you to unmute. The class will be more easier. You can speak.
Iron.
Television,
Electric iron. Okay.
Gas cooker.
oven,
Television,
television,
washing machine,
television,
microwave,
Heater.
One at a time. Wait.
refrigerator,
I'll give. Adi, wait. I'll give the hook. Y'all tell the appliance accordingly. Electric iron, something connected with heat. No. Tell me something connected with rotation.
Toaster.
washing
see the
machine,
microwave,
Fan.
Rotation.
fan,
Right.
iron,
Adi, rotation. I'll give the hook. Y'all talk according to that. Something connected with rotation fan. Something connected with sound.
radio,
radio,
Radio. Something connected with light.
Bulb.
Well, additionally, I'll write television. I won't talk about television as well. Right. So these are all common electric appliances in most of our houses. Common electric appliances in most of our houses. They do a energy conversion. Nothing we can tell energy transformation. They do a energy transformation. Electric iron. What is the input energy?
Electrical energy.
electricity,
Electric energy. Input is electric energy. What is your output there? What you get out?
heat energy, heat energy,
Heat energy. Fan. What's the input?
electric energy,
Electric energy. What's the output? What you get?
kinetic energy,
Kinetic. Now, some people will tell wind energy. Now, wind energy, it's okay to write it in grade 6. Now, you all are grade 11. Now, you know what happens in wind. What is wind? Air particles moving. If something is moving, what is that energy called as?
kinetic energy,
Be specific now.
Kinetic energy.
Kinetic energy. Radio, again, input electric.
electric energy,
Electric energy.
Output
Sound energy.
bulb. Input is electric. I want
Energy.
light energy,
light
energy,
I want you all to write the output. Television input is electric.
Energy.
I want you all to write the output. Sorry. So looking at all these electric appliances, what we can tell, all their input is electric energy. So that's why we call them electric appliances, because they work using electric energy and they convert the electric energy into some other form of energy. Sorry, take the tute. I hope all of you have the tute. Take the tute. Power and energy of electric appliances. Use different electric appliances to do various jobs in our daily life. Electrical energy is converted to some other form of energy in electric appliances. Write the appliances, write the conversion. Work. So bulb output is light energy. Light energy. What about television? TV. What's the output? Television, what's the output? What can we write?
Light and sound.
Light
Light
or
and
sound
sound.
energy.
Sound energy.
Both.
From the screen, what we get is light.
Light.
So there is light energy. Not only light energy, together with that, the speakers, from the speakers we can hear, which means it
Sound energy.
plus sound energy as well. I don't think one electric appliance, only one energy output will be there. There can be more than one energy output. Television, light and sound both. Right. So these are some very basics. Grade 6 work. Electric appliances, they convert electric energy into some other form of energy. Right. Now we have two important things to learn in this section. Number one, power in an electric appliance. Power in an electric appliance. Now listen very carefully. Eyes on the screen, ears on the speaker. Listen very, very carefully. Power of an electric appliance. What is power in an electric appliance? What's the definition of power in an electric appliance? Two definitions are there. Number one, work done in a unit time by an electric appliance is the power of that appliance. Work done in a unit time. 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 One definition for power of electric appliance. Now, at the moment, put it to the mind. Don't keep these kinds of lessons to separately study. You don't have time to separately study these kinds of lessons. Now, in the class, with me, memorize it. What is power? Work done in a unit time. Now, if we are talking about power in electric appliances, so work done in a unit time in electric appliances, power of a electric appliance. Another definition is there. Another definition is there. Both are the same. Just the words are different. Another definition, energy consumed per unit time. Energy consumed per unit time, power. So what are the two definitions for power? Work done in a unit time or energy consumed per unit time in an electric appliance is the power. Work done in a unit time or energy consumed per unit time in an electric appliance is power. You can mathematically calculate the power. You can mathematically calculate the power. Power of an electric appliance is equal to, again I repeat, power of an electric appliance is equal to the voltage of that appliance multiplied by the current consumed by that appliance. Power of an electric appliance is voltage multiplied by current. If I symbolically write down power, P is equal to voltage V multiplied by current. What is the symbol for current? Capital I. Grade work. Current symbol is capital I. The power is voltage V multiplied by current I, P equal VI. Very important equation in this lesson. Power P is equal to voltage into current, VI. What is the unit of power? Not a new thing. In grade 10, you all learned the unit of power. Try to tell me. Try to guess and tell me. What's the unit of power?
Joule.
What?
Watt.
Unit of power is watt. Watt. Symbolized as capital W. Unit of power is watt. Symbolized as capital W. First we will write this and then we'll do some questions. Right. Take now power output of an electric appliance. What is power of an electric appliance? Two definition. We'll write both. Write down. Listen and write down. Write the first one. First definition. Work done in a unit time. Work done in a unit time. Work done in a unit time. Or energy consumed per unit time. Energy consumed per unit time. Energy consumed per unit time. By an electric appliance. By an electric appliance. By an electric appliance is power. Is power. Is power. Right. Under that a box is given. In that box, I want you all to write the equation. First write it in words. Power is equal to voltage into current. And then write it symbolically, box it and write the unit. Work. Okay. Right. Enough time. Right. We'll solve some problems. Read example question 1. Read example question 1. Calculate the power of a bulb working at 12 volt. Working at 12 volt. Voltage is given. With a current flow of 2 ampere. Current is given. Lama, V is given, I is given. They are asking P. How to work? Write the equation. Write the equation. Power P is equal to VI. Power P is equal to voltage 12 volt multiplied by current is 2 ampere. If I do the math there, power is equal to 24 watt. 24 watt. I'll do the second one. Send me the answer. These are simple MCQ type questions. Do send me the answer. Right. Calculate the power of an oven operating at 230 volt. Voltage is given 230 volt. Power supply with a 2 ampere current. Current is given 2 ampere. Work power. P is equal to voltage. V into current I. Power is equal to voltage is 230 volt multiplied by current consumption is 2 ampere. So if I do the math there, 230 into 2, 230 into 2 is 460 watt. 460 watt. Now, some of you have asked, so is it a must to write equation? Lamai, listen. Structured this equation is a question. When you are doing any calculation, please write the equation and work. When you are doing calculation in structured disease equation, please write equation and work. With the equation you start. MCQ, no need, no. MCQ, it's your method, no. You don't need to write equation. If you want, you can write equation and work. If you want, you can do the full thing in the mind. Now, if this is MCQ question, no need to write these things, no. When you're reading, you do in your mind. Voltage 12 volt, current 2 ampere, multiply in the mind 24. Underline the answer 24. Here 230, 2 multiply in the mind 460. Underline the answer 460. If it is MCQ question, no need to write anything. Structured disease, please write equation and work. Right? That is power. That is power. Power of an electric appliance. Same. I told you two things are there for us to learn. One, power. Second, energy consumption. Energy consumption. Energy consumption. How to calculate the energy consumed by an electric appliance? How to calculate the energy consumed? Energy consumed means the electrical energy consumed. Because all the electrical appliances input electrical energy. We can calculate the electrical energy consumed. How to calculate the electrical energy consumed? Very simple. Electrical energy consumed is equal to power multiplied by time that the appliance is working. Energy consumed is equal to power multiplied by the time that the appliance is working. So if I write it in symbolic form, energy E is equal to power P multiplied by time T. E equal PT. E equal PT. E equal PT. That is one equation. There's another equation. From this equation, you get the second equation as well. See, energy E is equal to PT. Energy E is equal to PT. Now see, energy E is equal to PT. You all tell me P. What is P? What's the equation for P? What's the equation for P? What's the equation for P?
Voltage into ampere.
Voltage into current.
P is voltage into current. So instead of the letter P, I can write VI. Instead of the letter P, I can write VI. Instead of this, I can write VI. Then T will remain as it is. T. Agree with the rearrangement of the equation?
Yeah.
Yes, sir.
Energy is equal to PT. Instead of P, I write VI. Then energy is equal to VIT. Second equation. So two equations are given. According to the question, you use this equation. Now, in the question, if they give you just the power and the time and ask you to calculate the energy, you use the first equation. If they give power, time and ask you to calculate energy, you use E equal PT equation. If they give voltage, current, time and ask you to calculate the electrical energy, you use second equation. If they give VIT, ask you for E, you use the second equation. If they give you P and T, ask you for E, use the first equation. So according to the question, use the equation. You all tell me, what's the unit of energy?
Joule.
Energy,
Joule.
energy is measured in joules. Any energy is measured in joules. Not only electrical energy, any energy unit is joules. So here also you get the unit. So you get your answer in joules. Now some students have a confusion between power and energy. So what is power? What is energy? Some people have a confusion. Now listen, this part is very important. What is power? What is energy? Hariting equation, you all know power is equal to VI, energy is equal to PT. You all know the equation. But what do they mean? What do they mean? What's the basic meaning of it? Listen. Power. Power is a property of the appliance. Power is the property of the appliance. According to the power of the appliance only, you give the voltage and the current. Power is a property of the appliance. Now, when you are going and buying an electric appliance, you are buying a fan. In the fan, they will write and keep. The power of this fan is 16,000 watt or 16 kilowatt. You go and buy a AC. AC is 2,400 kilowatt. You will see the power there. Power is a property of the appliance. Then energy. Energy is the energy they consume. From outside, what you give is the energy. The consumed quantity is energy. What it consumes is the energy. The property of the appliance is power. If the power of the appliance is high, energy consumption is also high. If the power of the appliance is high, energy consumption is also high. Now, for example, if you take filament bulb, LED bulb, filament bulb and LED bulb, filament and LED bulb. Now, some people don't know what is filament bulb. What is filament bulb? A glass bulb is there. Inside that you have a filament. That's filament bulb. LED bulb is a normal LED. Filament bulb power is high. LED bulb's power is low. Now, what does that mean? Filament bulb's energy consumption is also high. It will consume a lot of electrical energy to burn and give some intensity of light. LED power is low. As the power is low, its energy consumption will also be low. So just with a little amount of energy, electrical energy, it will give a huge brightness, give a huge intensity of light. So that's the difference. So you all tell me, when you go to buy an electric appliance, you should select an appliance with high power or low power.
With low power.
Low power.
Low power.
Low power.
Why you select low power? What you are trying to reduce by low power?
Energy consumption.
Energy consumption.
Energy consumption.
Energy consumption.
Why? Because your electricity bill is calculated according to the energy you consume. Again, I repeat, your electricity bill is calculated according to the energy you consume. The person who comes and bill your electricity, he will look at the meter and using the energy you consume only, he gives you the amount you have to pay. Now, he won't come home and ask, what are the powers of the electrical appliances you have? He won't come and say, have you all bought a fan? What is the power of the fan? Have you all bought a new TV? What's the power of TV? That he is not interested about the power. The person who builds your electricity consumption, he is interested about the energy. Okay. So when you are buying, you have to be concerned about the power. You buy low power so that it consumes less energy. Understand the difference? Hurry. So energy is equal to power into time. E equal PT, E equal VI. The unit is joules. Now go to Electrical energy consumed by electrical appliances. There's a box given. I want you all to write this in that box. Okay. Right. Enough time. I want you all to do example 1, example 2, and example 3. Now, when y'all are working, y'all tell me the time you write, you should write in what unit? What is the unit of time that you have to write there? SI unit. Remember, time should be written in SI unit. What's the SI unit of time? What's the SI unit of time? Seconds.
Seconds.
So sometimes they will give it in minutes. You have to
Second.
convert to seconds. Sometimes they will give it in hours. You have to again convert to seconds. Remember, time should be in seconds. Hurry. Work. Example 1, example 2, example 3. Work and send me the answer. I'll work on the first one. Most of you send me the answers. Example question. Power of a headlight of a motor car is 50 watt. Power is given. Find the energy consumed. They are asking E value. When the lamp is operated for 20 seconds, time is given. What's the equation you use? First tell me that. First equation, the second equation. What's the best equation for this?
First equation.
First equation.
First equation. Power equal, sorry, energy neither. They're asking energy. Energy equal power into time. E Vt. So from there, E is equal to power 50 watt multiplied by time 20 seconds. When you do the math there, Y is equal to 1000 watt.
Joules.
Sorry, energy? Joules.
1000 joules.
Energy is equal to, they're asking energy. Energy is equal to 1000 joules.
That we should need to give a time in second or must give in hours.
It's a must to do in seconds. This question.
Okay, thanks.
Second one. An electrical motor operating with a power of 200 watt. Power is given 200 watt. For 2 hours. Onnala, my time is given in hours. 2 hours. 2 hours. How to convert hours to second?
Multiplied by 60 into 60.
Scholarship section, ne? Converting hours into second. Converting hours into seconds. How do you convert?
600.
1 hour is equal to 60 minutes. That 60 minutes, if you are converting into seconds, you multiply that 60 by 60. 60 into 60, how much?
7200 seconds.
3600 seconds.
seconds. Keep that in mind. 1 hour is 3600 seconds. Directly keep this in mind, so calculations will be easier. Don't separately multiply 60 by 60. Just keep in mind 1 hour is 3600 seconds. 1 hour 3600 seconds. 2 hours how much? I think that question is 2 hours.
7200 seconds.
7200.
2 hours is 7200 seconds. 1 hour 3600, then 2 hours multiplied by 2. 7200 seconds. 7200 seconds. 7200. So if I write the equation, energy consumed, E is equal to PT, power is there, time is there. I use the first equation. Energy, E is equal to power 200 watt multiplied by time 7200 seconds. 7200 seconds. So if I do the math there, energy is equal to 2 into 72. 140.
1.44 mj.
140. 144.
Yes.
144,000.
Yes, sir.
44.
144. 1, 2, 3, 4. 4 zeros will come. 1, 2, 3, 4. So how do I read this?
1,400,000.
140,000 joules.
444,000.
144,000.
1,440,000. Check your zeros. Now listen. This is a very big number. If it is a big number, I can write it in kilojoules. I can write it in kilojoules. It's not a must. They are not asking it in kilojoules,
Sir.
but you can write it in kilojoules.
Sir.
Right. How to convert joules into kilojoules? How to convert joules to kilojoules? How to
Joules
convert joules to
divided by
kilojoules?
1000.
Tell me, 1 1 kilogram. How many grams?
1000 grams.
1000 grams.
1000 grams. That means this kilo word means what? Kilo
1000.
word means 1000. Remember the word kilo means 1000. 1 kilogram means 1000 grams. 1000 grams. Kilo, the word kilo means 1000. 2 kilogram means 2000 grams. The word kilo means 1000. 3 kilogram means 3000 grams. So the word kilo means 1000. Ehenang tell me 1 kilojoules. How many joules?
1000 joules.
1000 joules.
Then do the conversion there. 1,440,000 joules. Again, one more time. 1, 2, 3, 4. 1, 2, 3, 4. Convert it. How to convert to kilojoules? How to convert to kilo?
Joules divided by 1000.
Divide by 1000. So 3 zeros will cancel off. When 3 zeros cancel off, 1440 kilojoules. 1440 kilojoules. Think like this. Think like this. 1,440,000 grams. Give me that in kilograms.
1000.
You cut off 3 zeros. You divide by 1000. You cut off 3 zeros. 1440 kilograms. Same way, 1,440,000 joules. Give me that in kilojoules. You cut off 3 zeros. 1440 kilojoules. So you can keep the answer in kilojoules as well. You can keep it in kilojoules as well. Both are correct. Third question. A fan operates at a voltage of 230 volt. Voltage is given 230 volt with 2 ampere current. Current is given ampere. Question A, calculate the power. Now the first equation. What's the equation for power? Power is equal to voltage multiplied by current. Power is equal to voltage. Voltage is 230 volt multiplied by current is 2 ampere. When you do the math there, power is equal to 30 multiplied by 2 is 460 watt. B question, calculate the energy consumed in hours. Energy consumed in hours. Now see, in 1 hour. Energy consumed in 1 hour. Now see, time is given. Already I have calculated the power. No? So power is there, time is there. I'll use the first equation. Energy equal PT. Power is there from the first question. Time is there 1 hour. I'll use energy equal PT. So if I apply the values there, energy is equal to power 460 watt multiplied by 1 hour. Tell me 1 hour how many seconds?
3600 seconds.
1600 seconds. So if I do the math there, 46 multiplied by 36.
$1,656.
1,656,000 joules.
One million 656,000 joules. Big number, you can keep it in kilojoules. Tell me that in kilojoules.
1,656
joules.
Kilograms.
1656, 3 zeros cut off, kilojoules.
kilojoules.
Less than those who got all correct.
Me.
Is it wrong if we did it in second equation? No problem, you are correct. Right, good. Others check and make the corrections. By the time, if you have got any doubts, ask me. Raise the hand and ask me. Now, all of you put the hands down.
Sir.
Yeah.
Sir, I can understand the second one, sir.
Second question.
Example 2. Set example 2.
Right. An electric motor operating with a power 200 watts for 2 hours. Power is given, time is given, but time is given in what? Hours. Calculate the energy consumed.
Okay.
Energy is equal to PT. Power is 200 watt. Time, can I write it in hours? No. I have to convert to second.
7,000.
So if I convert 2 hours to second, it's 7,200 seconds. Now multiply to get this answer.
Okay, sir.
Yeah. Who else? Minha, what's the doubt? Minna, you can ask the doubt.
No, sir, I have done.
Yeah, right. Okay. Zamrat, you got any doubts? So sir, raise the hand if you have doubts, unmute and ask. Is it a must to convert to kilojoule? No, it's not a must. Unless and otherwise they tell in the question. Sometimes they'll tell in the question. Give the final answer in kilojoules. If so, you convert to kilojoules. Otherwise, no need. But usually big numbers, it's better to write it in kilojoules. Big values, no. First time I didn't convert, no, because small number. These are millions. So better to convert to kilojoules. Hurry. So power done, energy done. Next. Important concept. Kilowatt hour. Important concept. Kilowatt hour. You write it as simple K, capital W, simple H, KWH. Kilowatt hour. What is this kilowatt hour means? Kilowatt hour is a unit used to measure electric energy. It's a unit used to measure electric energy. Not only electric energy, any energy you can use, but mainly it's used to measure electric energy. Some students think kilowatt hour is for power. Wrong science. Kilowatt hour is the unit for energy. We already know joules is a unit for energy. Other than joules, even kilowatt hour is a unit for energy. It's a unit used to measure specially electric energy. Now, where do you use this? Mainly, kilowatt hour is the unit used to measure electric energy consumption in your houses. So, domestic electric energy consumption is measured in kilowatt hours. Domestic electric energy consumption is measured in kilowatt hours. Now, when you see your electricity bill, have you all seen in your bill, they will mention the number of units you have consumed, 90 units. Month of September, you have used 90 units of electricity. 100 units, 80 units. What is that units means? Now, what do you mean by 90 units? 90 units means, Lamai, 90 kilowatt hours of electric energy you have used. 100 units means 100 kilowatt hours of electric energy you have used. 80 units means 80 kilowatt hours of electric energy you have used. Sorry, units, the word unit means kilowatt hours. So basically, our electrical energy consumptions in the houses are built according to the kilowatt hours of electrical energy you use. According to the kilowatt hours of electrical energy you use. Take your electricity bill and see. Those things you have to see. You should know how much of electrical energy you are consuming in your house. Take your bill. Maybe by now it should have come. September is over now. Today done. Tomorrow October is starting. So check your electricity bill. Check how much of units you have consumed. That unit means that much of kilowatt hours of electrical energy you have consumed in that certain month. So kilowatt hour is a unit used to measure the domestic electric energy consumption. Domestic electric energy consumption. What is the meaning of 1 kilowatt hour? What is the meaning of 1 kilowatt hour? What does this 1 kilowatt hour tells us? What does 1 kilowatt hour tells us? What's the meaning? Listen. 1 kilowatt hour means the amount of electric energy consumed, amount of electric energy consumed in 1 hour, in 1 hour by a electric appliance, by a electric appliance with power 1 kilowatt. What do you mean by 1 kilowatt hour? The amount of electric energy consumed in 1 hour by an electric appliance working with a power of 1 kilowatt. Again, I repeat, follow the words I'm using. Carefully follow the words I'm using. What is 1 kilowatt hour means? Amount of electric energy consumed in 1 hour by an electric appliance working with a power of 1 kilowatt. What is 1 kilowatt means? What is 1 kilowatt means? 1 kilowatt is 1000 watt. I'll explain. 1 kilowatt means 1000 watt. So if you take an electric appliance of 1000 watt, when you are using it for 1 hour, amount of electric energy it consumed is 1 kilowatt hour. Again, I repeat, if you take an electric appliance of 1000 watt, when you use it for 1 hour, the amount of electric energy it has consumed is 1 kilowatt hour. For example, your fan. Just imagine your fan's power is 1000 watt. I told you, you can check that. There will be a stick on the fan. Or at least check the plug point. If it is a standard fan, you can see the power. You can see the power. So let's take your fan is 1000 watt power. You have switched it on for 1 hour. 1 hour it's rotating. 1 hour it's working. Then the electric energy it has consumed. Electric energy it has consumed is 1 kilowatt hour. Okay. So what is 1 kilowatt hour means? Amount of electric energy consumed in 1 hour by an electric appliance working with a power of 1 kilowatt. That is 1000 watt. Okay. Now I told you, kilowatt hour is a unit used to measure energy, electric energy. It's a unit used to measure electric energy. Tell me the other unit used to measure electric energy. There's another unit for electric energy.
Joules.
Joules is another unit used to measure electric energy. Now, what is the relationship between kilowatt hour and joules? What's the relationship between kilowatt hour and joules? Listen very carefully. What's the relationship between kilowatt hour and joules? I'll mathematically show you all. The relationship between kilowatt hour and joules. Look very carefully. Relationship. I think that part you can't see. I'll lift the board. Right. Relationship between kilowatt hour and joules. Relationship between kilowatt hour and joules. Right. Okay. Tell me, what's the equation for electric energy? What's the basic equation for electric energy? Electric energy consumed?
Equal PT.
Equal PT. Electric energy consumed equal PT. Tell me, power. Power is written in what unit? What's the unit for power? Time is written in what unit? What's the SI unit of time?
Second.
Second. So the basic unit you are getting for electric energy is what second? E?
Yeah.
Basic unit you get for electric energy is what second? See, power is what? Time is second. When you multiply the base unit you are getting for electric energy is what second? This what second only you write as joules. This what second is what you write as joules. In all those questions.
Is what second is equal to joules?
Yes, I'll explain that. In all these questions here, see? In all these questions here, you are getting the power in what? You are getting the time in second. That what second only you are writing as what? Joules. Okay, the second question. You are getting the power in what? You are getting the time in second. That what second only you are writing as what? Joules. So basically, what second is equal to what? Joules.
Joules.
What second is equal to joules? Agree?
Yeah.
Yeah.
Yes,
1
sir.
watt second is 1 joules. 2 watt second is 2 joules. 10 watt second is 10 joules. 1000 watt second. 1000 watt second is 1000 joules. 1,440,000 watt second is 1,440,000 joules. Watt second is joules. Equation number 1. Watt second. Now, we are not finding this relationship. What's the relationship? I'm going to find the relationship between kilowatt hour and joules. Right. Now, going
Is
to that.
we write what second
I'll come to the questions. I'll come to the doubts. This one just keep in mind. Now we are going to find the relationship between kilowatt hour and joules. That is our work. What's the relationship between kilowatt hour and joules? Look. 1 kilowatt hour. 1 kilowatt hour. If I remove the kilo part here, if I remove the kilo part here, I will have the watt. And if I convert the hours to second, hours I can convert to second. If I convert the hours to second, I will end up with what second? 1 kilowatt hour. I remove the kilowatt, I convert hours to second, end up with what second? Now what second is what? Joules.
Joules.
So what I'm going to do now is, I'm going to remove the kilo part and convert the hours to second and get watt second. That watt second, I know it is equal to joules. With that, I'm going to find the relationship between kilowatt hour and joules. Look what I'm going to do. I remove the kilowatt, I convert hours to second, then I get watt second. That watt second, I know that is equal to joule. With that, I'm going to find the relationship between kilowatt hour and joules. Right. So how to do this? Look, okay? How to do this? My first job, I need to remove the kilo part there, right? 1 kilowatt hour. How to remove the kilo part? Y'all tell me, what is the meaning of kilo? I already told you.
1000.
1000.
Everyone, what's the meaning of
1000.
1000.
1000.
1000.
Ehinang lamai, instead of the part kilo, I can write 1000. Instead of the part kilo, I can write 1000 and remaining parts what hour. Agree?
Yes.
What did I do? I removed the kilo. Kilo means 1000. So instead of the part kilo, I wrote 1000, kept the other thing as it is, whatever as it is. Again, look, 1 kilowatt hour. I removed the part kilo. Instead of the part kilo, I wrote 1000 and kept whatever as it is. Kilowatt removed now. Next, what I should do? I should convert hours to.
Seconds.
Now, next job is this. Target is that. How to convert hours to second? Y'all tell me. 1 hour. How many seconds?
3600 seconds.
3600 seconds. So, how to convert this hour into second? Instead of hour, I can write
3600
600.
3600.
I'll write like this. I'll write 3600. What I will keep as it is. Second, I'll write separately. Look at the step. 1000 is there as it is. Instead of hour, I wrote 3600. Second, what is kept as it is. Again, see, 1 is kept as it is. 1000 is kept as it is. Instead of hour, I wrote 3000. Second, what is kept as it is. Now I'll do the multiplication. 1 into 1000 is 1000. 1000 into 3600 is 3600. Another 000. What second? Y'all tell me, what second is what?
Joules.
So
Joules.
instead of what second,
Joules.
what can I write?
Joules.
Maybe I can go one more step ahead. 1 kilowatt hour is equal to, we'll write it in scientific notation. Tell me this in scientific notation.
10 to the power 5. 36 into 10 to the power.
In scientific notation, you write one digit, keep a decimal, write the other digits after that. Then you
20.
write it as a multiplication of 10 to the power.
Power
10 to the
6.
power how much? 1, 2, 3, 4, 5, 6 to the power 10 to the power 6 joules. So tell me, 1 kilowatt hour is how much of joules?
3.6
6
into
into 10 to the power 6 joules.
1 kilowatt hour is 3.6 into 10 to the power 6. Why 6? Why 6 lamai? I kept a decimal here. A decimal here means how many digits are there after that? 1, 2, 3, 4, 5, 6. 10 to the power 6. 10 to the power 6. Sorry. Will they ask this conversion in your exam? No, they won't ask it. But can you see, doing these conversions are interesting. You make a connection there, you build a connection there, then you solve it and come to this answer. There is a concept there. There is an interest there. That's why I showed you all. This is how you do. Nattang I can write down. Alamai 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Kolamai liyagand. Hema I can tell. But is there any work in it? Now, when we do like this, Anna, this becomes this, this becomes this, this becomes this. So you know the logic there. So in case in the exam, if they ask any other conversion also, you can do this. You don't know how to do conversions now. So with this, you understand. Not big deal. What is the relationship? See, not a big thing. 1 watt second is joules. 1 joule. Understood that part?
Yes.
Yes,
How
sir.
did I get this? E T P is what? Is joule. 1 watt second is 1 joule. Now see what they have given us. They have given us kilowatt hour. What I am going to do? I convert to joules. Joules means I am actually converting into watt second. That is what I am going to do. So now compare kilowatt hour, watt second. What are the changes I have to do? First I have to remove kilo. Then I have to convert hours to second. Then you do the required things. First I remove kilo. If I remove kilo, 1000 will be added there. Watt hour will be remaining. Next I have to convert hours to second. How to convert hours to second? 1 hour is 3600 second. So 1000, 3600 watt second. Then you do the remaining maths. Clear? Hurry. Now go to the measuring electrical energy in kilowatt hour. Commercial unit of measuring electric energy. Electric energy is measured in kilowatt hours. Underline or highlight it. Electric energy is measured in kilowatt hours by domestic electricity meter. Your meter will give that. 1 kilowatt hour is the amount of electrical energy consumed during 1 hour by an electric appliance with the power of 1 kilowatt. Under that a big box is given. I want you all to write the relationship between kilowatt hour and joules. Write all these steps. Try to do by your own. These are interesting things. Don't get it. Don't think like this is very hard. I can't do this. No, don't think like that. You get it to the mind. Step by step, do it. Step by step, do it. Try to do by your own.
Yeah.
Everything goes to one. Only this box. Only the first box. Everything goes to this second box. Don't write anything. Second box, another equation will come. Only in the first box. Meanwhile, someone asked me a doubt while I was talking. Now you can ask Puta.
3.6 into 10 to the power 6 is constant to 1 kilowatt.
I don't get you.
Is the value is constant?
Is the value constant? You're asking, is it constant value?
Yes.
1 kilowatt hour means this. Then 2 kilowatt hour means twice of it. 3 kilowatt hour is thrice of it. Is a constant value.
Sir, can we keep it in kilojoules, sir? 3,600,000?
Yeah, you can keep it in kilojoules. Yes. But my job is I am converting kilowatt hour to joules. So what I'm doing here is I'm converting kilowatt hours to joules. See, that's the heading I wrote. Relationship between kilowatt hours and joules.
Okay.
Okay. You can keep it in kilojoules, no problem. Okay, remember someone asked me a doubt while I was explaining. You can ask that.
Excuse me, sir.
I
Yeah.
have been sent that
Sorry.
I have been sent that in text.
Can you resend me?
Okay, sir.
Sir, I didn't understand what is meant by 1 kilowatt hour. Sir.
Sorry.
I didn't understand what is meant by 1 kilowatt hour.
1 kilowatt hour. Okay, first write this. I'll re-explain that.
Okay.
Sir, excuse me.
Yeah.
Is kilowatt hour also a unit of energy?
Yeah, that's a unit of energy.
Excuse me?
Yeah, go ahead.
Send, sir.
If you write watt second, E the joules in final exam, is it acceptable answer? Can you asking whether can we write watt second instead of joules? No, don't write it. Because the final answer should be kept in joules. Energy, the final answer is joules. Now, for example, force. For force, I can write fundamental unit kg ms to the power minus 2. That's the fundamental unit of force. Derived unit is Newton. But what unit you keep your final answer?
Newton.
Newton. Newton. You don't keep it like this. You go for the final endpoint. This is the SI unit. So you keep it in SI unit. Watt second is not a SI unit. It's not the final answer unit. Final answer unit is joules. So you keep it in joules. Hurry. Is anybody writing this still? Send a thumbs up those are done. How it comes as 3.6 at last. Scientific notation, Puta. Now 3600. Write it in scientific notation. How do you write it in scientific notation? Jump 3 decimal. In scientific notation, only one digit you keep at the digit. So 3, you jump 3 decimal, 3.6. How many decimals you jump? 3 decimals you jump. So multiply by 10 to the power 3. Scientific notation. How do you write it? 3.6. How many decimals you jump? 1, 2, 10 to the power 4. So now write this in scientific notation. 3.6, 1, 2, 3, 4, 5, 6, 6 decimal you jump 10 to the power 6. Okay, no? Someone asked me about 1 kilowatt hour. The meaning of 1 kilowatt hour. 1 kilowatt hour. 1 kilowatt hour is a unit for energy. 1 kilowatt hour is a unit for energy. So what is 1 kilowatt hour mean? Energy consumed. How much of energy is consumed? In 1 hour. That's why the word 1 hour is given. Hour is given. In 1 hour. Now time is going 1 hour. By an appliance that has a power of 1 kilowatt. I told you power is a property of the appliance. So let's say you have an appliance of 1 kilowatt. It is working for 1 hour. Then it has to consume some energy. How much of energy it has consumed? 1 kilowatt hour energy. Again, you have appliance of 1 kilowatt. It is working for 1 hour. It has to consume a certain amount of energy. The amount of energy it has consumed is 1 kilowatt hour. Understood the person who asked me?
Yes, sir. Understood. Thank you.
Welcome. Right. Next. Sometimes in your questions, sometimes in your question, they will give the power in what? They will give power in what? Power will be given in what? And they will ask you, also together with power in what? They will give the time in hours. These two are given. Power what is given, time in hours is given. And they will ask you to calculate the electric energy in kilowatt hour. Power will be given in what? Time will be given in hours. Energy calculation, they will ask you to do it in kilowatt hour. They give the power in what? Time in hour. Ask the energy in kilowatt hour. At that kind of instance, how do you do the calculation? How do you do the calculation? Very simple. Energy in kilowatt hour is equal to energy in kilowatt hour is equal to power in what it is given divided by 1000 multiplied by number of hours. Time is already given. Multiplied by number of hours. That gives you kilowatt hours. Energy in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours that appliance is working.
Excuse me, sir.
Energy. Wait,
Your voice is not clear.
I mean, is my voice not clear?
It's clear, sir.
Yes, sir.
It's clear.
So energy in kilowatt hour is equal to power in watt. They have given the power. You divide it by 1000. You multiply it by number of hours that appliance is working. Number of hours is given. Power in watt is given. So you can calculate energy in kilowatt hours. If I do a question and show you all, let's take power of an electrical appliance is 2000 watt. Power is given in watt. It is working for 2 hours. Time is given in hours. I am asking you to calculate the electric energy in kilowatt hour. I'm asking you to calculate the electric energy in kilowatt hour. Then how do you calculate the electric energy? Electric energy is equal to power in watt. Power in watt divide by 1000 multiplied by number of hours. Power in watt is 2000 watt. Divide by 1000 multiplied by number of hours. How many hours it is working? 2 hours. So if I do the math, how much I get? Triple zero cancel off. 2 into 2. 4 kilowatt hour. Get the answer in kilowatt hour. So one more time, energy in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. Ehnang, y'all tell me the answer for this. Tell me the answer for this.
30
kilowatt hours.
30 kilowatt hours.
30 kilowatt-hours.
Everyone. Better send the answer.
Sir,
Yeah. Perfect. Power in watt, sorry. Electric energy in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. Power in watt 5000 watt divide by 1000. Number of hours 6 hours. So if you do the math there, 000 cancel off. 5 into 6, 30 kilowatt hours. Good. Understood the technique? Energy in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. Now, there is a second box given. In this second box, I want you all to write this equation. Second box, write this equation. This equation goes to the second box.
sir,
Yeah, go ahead. Yes, Buddha, go ahead.
Sir,
Yeah,
why
go ahead.
are we applying power in watt Sorry, power in, why are you dividing power in watt by 1000?
Good question. Why are we dividing by 1000? Why that 1000 is coming?
Convert into kilowatt.
Anna Hari. Power is there in what? Power is there in what? Ne? But I need the final answer in kilowatt. I want the final answer in kilowatt. You all tell me grams to kilograms. What do you do? Grams to kilogram. What do you do?
Divide by
Divided
1000.
by 1000.
Anna Hari. Divide by 1000. Ehenang, you have the power in watt. Watt to kilowatt. What you have to do?
Divide by 1000.
Divide by 1000. And you have to add the unit hours to it. You have to add the unit hours to it. Then what you do? Multiply with hours. Understood the technique?
Yes.
You have the power in watt. I want to convert to kilowatt, so I divide by 1000. I have to add hours to it, multiply by number of hours. Harined. Now we'll solve some more questions. Calculate the energy consumed in kilowatt hour when a bulb of power 100 watt works for 3 hours. Calculate. Power is given in watt, time is given in hours. They're asking the energy in kilowatt hour. Use the equation.
0.3 kilowatt hour.
Better send me, Puta.
Sir, I've been disabled from chatting, sir. I don't know why.
Disable?
Yes, sir. Every time it happens.
What's your name? Just unmute and talk.
Aisha, sir.
I'll send you a message. Recently, however, Zoom has updated their chatting feature. Now, big problem from our end. If I want to see a message, each one of you have to click and see. Before it was not like that. Your name appears, your chat comes. Your name appears, your chat comes. Now it's not like that. The chat is divided. You have to click the name, check the chat. Click the name, check the chat.
It's not working, sir.
From my end, chats are coming to me, Puta. Maybe from your end, you have to check your Zoom.
Okay, sir. I'll do that.
Okay. So if they give the power in kilowatt itself. Good question. If they give the power in kilowatt, then now you know the changes. If they give the power in kilowatt, do you need to divide by 1000? Is that
No.
step needed?
No.
You only add the hours. Or otherwise, you can convert the kilowatt to watt, kilowatt to watt, then divide by 1000 and do. Kilowatt to watt, then divide by 1000 do. Right, hurry. Calculate the energy consumed in kilowatt hour when a bulb of power 100 watt works for 3 hours. I'll do it separately. A bulb of power 100 watt works for 3 hours. 3 hours. Works for 3 hours. Right. Electrical energy consumed is power in watt. Now in the exam, don't write short form. You have to write it fully. Power in watt divide by 1000 multiplied by number of hours. You write fully number of hours. So electric energy is equal to power in watt. Power in watt is 100 watt divide by 1000 multiplied by number of hours, 3 hours. So if I do the math there, electric energy is equal to 0000 cancel off. 3 divided by 10 is 0.3 kilowatt hour. 0.3 kilowatt hour.
Excuse me, sir.
Yeah. Go to the second question. Try second question. Those are done with first one. Go to the second question. Try second question. Yeah. You can talk.
We write that instead of kilowatt hours, joule, because we proved that kilowatt hour is equal to joule.
Hmm? You're asking whether we write joules?
Yes. Instead
No,
of that,
no. No, you can't. No. Why? Why? One reason, two reasons I can tell. One reason, 1 kilowatt-hour is how much of joules?
3.6 into 10 to the power.
So can you write how much you got? 0.3 kilowatt-hour is 0.3 joules?
Can't.
Can't. One reason. Second reason, read the question. Calculate the energy consumed in
Kilowatt.
kilowatt-hour. Need. Sorry.
Thank you.
Okay, welcome.
So can you show the second question?
Okay.
Done.
Second one. Calculate the energy consumed in kilowatt-hour when 3 bulbs. How many bulbs now? 3 bulbs of power 100 watt each. One bulb is 100 watt. So 3 bulbs are working for 3 hours, right? 3 bulbs are there. One bulb is 100 watt. They are working for 3 hours. You can do the question in two ways. 3 bulbs are there. 3 bulbs are there. Maridu. For one bulb, power is 100 watt. One bulb power is 100 watt. It is working for a time period of 3 hours. Time period of 3 hours. I can do the question in two ways. One, can calculate energy consumed by one bulb, then multiply it by bulb. Energy consumed by one bulb, how is the time is, I can calculate the energy, then multiply it method. Or I can multiply the power by 3. Why power by 3? One bulb 100 watt nang, 3 how much of watt?
300 watt.
300 watt. And then I can solve the question as well. So two methods of solving the same question. Either I calculate the energy for one bulb, multiply it by 3, or I multiply the power by 3 and do the
Can you use
question. Both
calculator?
are same. Both are same. Both are same. Either I calculate the energy and multiply by 3, or here itself I'll multiply by 3 and do the question. Sum or multiplication of 3 should be added. I'll do it in the first way. I'll calculate the energy for one bulb, then we'll find the energy for 3 bulbs. I'll do step by step so that you can understand it. Energy for one bulb. Energy for one bulb. We have to calculate it in kilowatt hour. Energy in kilowatt hour is equal to power in watt divided by 1000 multiplied by number of hours. Energy in watt is 100 watt divided by 1000 multiplied by number of hours is 3 hours. So if I do the math there, 0000 cancel off, we got the same answer before. 3 divided by 10 is 0.3 kilowatt hour. This is for how many bulbs? One bulb. Ehenang energy for energy 3 bulbs is equal to 1 bulb 0.3 kilowatt hour. 3 bulbs is you multiply it by 3. 3 bulbs you multiply it by 3. So you get 0.9 kilowatt hour. Got it? One bulb is 0.3, then 3 bulb 0.9. Yeah, some have done like this. This is also okay. All are same. You multiply here by 3, here by 3. Here by 3. That is what is here by 3. No? Directly you multiply here by 3. Somewhere multiplication by 3 should be added. Go to the last question. Think and do. Last question. Think and do.
$72 kilowatt-hour.
$72.0 kilowatt-hour.
I change the book.
Can
Excuse me, sir.
Yeah, you excuse.
How much would they charge for 1 kilowatt hour?
I don't know the calculation for that. It depends like this. It's not 1 kilowatt hour this much. It goes like tax calculation. It goes like tax calculation. For a cert, I don't know the correct numbers. I'll just give an
Excuse me,
example number.
Sir.
I'll give example number. Now let's
Shut
take.
up, sir. Shut up. I will explain. Okay.
Dr. Devaharan.
Dr. Divaran.
Some about halfway. Some are born not in 10 months. Halfway born people are there. I mean, any class there are people like that. බාග ඉපදිලා නිකන් උන්ට කතා කරන්නත් දන්නේ I mean. Hari, the question was how much they charge. Calculation is like this. Until I'm just giving a certain number, eh? You have to check the correct number. Until about 90 units, a certain calculation is there. Let's say until 90 units, the charge is per unit 20 rupees. Until 90 units, per unit 20 rupees. After you cross your 90 units, per unit 50 rupees. After you cross 120 units, per unit 100 rupees. Such a calculation is there. Just like tax calculation. First 500,000, a certain amount of tax is there. Second 500,000, additional tax get added, double tax. Next 500,000, 1,500,000, another tax get added, just like that. I think in maths you all do the calculation, tax calculation. Hari, do the C question. Done. If 4 bulbs each having a power of 100 watt, each having a power of 100 watt, 4 bulbs each having a power of 100 watt, are used for 3 hours, right? 4 bulbs each 100 watt, 3 hours. Four bulbs are used. For one bulb, they have given information like this. For one bulb, power is 100 watt, used for a time of 3 hours. Used for 3 hours. And 5 bulbs, each with a power of 60 watt. 5 bulbs, each with a power of each. For one bulb, they have told each with a power of 50 watt. 50 watt. No, each with a power of 60 watt are used for 4 hours. Each with a power of 60 watt. 60 watt used for 4 hours. 4 hours daily. This data is daily data. Again, read the question. 4 bulbs, each having a power of 100 watt, are used for 3 hours. And 5 bulbs, each with a power of 60 watt, are used for 4 hours daily. This information is given for daily. Find the electricity consumption during a month. They are asking the consumption in a month. Daily information is given. They are asking the consumption for month. What I will do is, first I will calculate the daily electrical consumption. First I will find daily electrical consumption. That I multiply by 30, I can get the monthly electrical consumption. Agree? First I'll calculate the daily electrical consumption. That I multiply by 30, then I can get the monthly electrical consumption. So 2 steps. First I find the electrical consumption per day. Then I multiply by 30, convert it in month. In that also there is an issue. You have to separately find for this bulb, separately find for this bulb. To separately find the electrical consumption for this bulb, separately find the electrical consumption for this bulb, add it and get the daily electrical consumption. Right, we'll work it out. First I'll find for this bulb. First I'll find for this bulb. For one 100 watt bulb, for 100 watt bulb, I'll solve the question. For 100 watt bulb, energy is equal to power in watt divided by 1000 multiplied by number of hours. Power in watt is 100 watt divided by 1000 multiplied by number of hours is 3 hours. So if I solve the question there, double zero cancel off, you get 0.3 kilowatt hour. This is for one bulb. Like this, how many bulbs are there? 4 bulbs are there. So for four bulbs, what I have to do? I multiply that value by 4, which gives me 1.2 kilowatt hour, equation 1. Now I have solved the equation for 100 watt bulb. What I have done? For 100 watt bulb, working for 3, calculated the energy consumption, but you have 4 bulbs, I multiply by 4. So this is for 4 bulbs, daily consumption with 100 watt power. Next coming to 60 watt power bulb. Next coming to 60 watt power bulb. Right, we'll work it out. For one 60 watt power bulb. For 160 watt power bulb. For 160 watt power bulb, I'll calculate the energy consumption. Energy is equal to power in watt divided by 1000 multiplied by number of hours. That is equal to power in watt, 60 watt, divide by 1000 multiplied by number of hours is 4 hours. So if I do the math there, 1010 cancel off. 6 into 4, 24. 24. 24 divided by 100 is coming. 24 divided by 100 will be 0.24 kilowatt hour. 0.24 kilowatt hour. This is for one bulb. How many bulbs they are talking about? They are talking about 5 bulbs. They are talking about 5 bulbs. So we'll calculate the energy for 5 bulbs. For 5 bulbs, energy consumption is 0.24 kilowatt hour is for one bulb. That I multiply by 5. Then the energy consumption is 24 into 5, 120. Again 1.2 need 1.2 kilowatt hour. Again 1.2 kilowatt hour. So now we know this 100 watt bulb, one day it consumes 0.3 kilowatt hour. So 4 bulbs consume 1.2 kilowatt hour. This 60 watt bulb, for one day it consumes 0.24 kilowatt hour. Then 5 bulbs consumes 1.2 kilowatt hour. This is separately for 100 watt, separately for 60 watt bulb daily. Ehenang, I can calculate the total daily energy consumption. Total, I write this step by step, daily energy consumption. What is my total daily energy consumption? Now tell me. 100 watt bulb energy consumption is 1.2 kilowatt. 60 watt bulb energy consumption is 1.2 kilowatt hour. Then altogether total is 1.2 kilowatt hour plus 1.2 kilowatt hour. Altogether how much? Altogether how much? 2.4 kilowatt hour. Equation 3. So now I know the daily electrical consumption. Total daily electrical consumption is 2.4 kilowatt hour. Henang, y'all calculate for 30 days. Y'all calculate for 30 days. I did in different method, no problem. Now your one way not exactly. You know, daily total electrical consumption is 2.4 kilowatt hour. Henang calculate for 30 days. You do multiply by 30. For 30 days. 30 days is 1 month. For 1 month, total electrical consumption is 2.4 kilowatt hour is for 1 day. You multiply it by 30 days. 30 days, that gives you 3 into 24, 2.4, 72 kilowatt hour. Again, see how I did the question. Again, see how I did the question. They are telling there are 4 bulbs. There are 4 bulbs with a power of 100 watt working for 3 hours daily. So for one bulb, I calculated the energy consumption. One bulb energy consumption is 0.3 kilowatt hour. Then for 4 bulbs, you multiply it by 4. So this is for 100 watt bulb. For 4 bulb, 1.2 kilowatt hour. Now coming to 60 watt bulb. 60 watt bulb. For 160 watt bulb, energy consumption is 60 watt divided by 1000 into it's working for 4 hours multiplied by 4. So energy consumption is 0.24 kilowatt hour. This for one bulb. Like that you have 5 bulbs. So 5 bulbs you multiply it by 5, 1.2 kilowatt hour. So the total daily electrical consumption is addition of this 1.2 kilowatt hour, addition of this 1.2 kilowatt hour, both together 2.4 kilowatt hour. That's the total daily energy consumption. They are asking for 1 month. So for 30 days, you multiply that number by 30. Then you get 72 kilowatt hour. That's the final answer. Now maybe you would have done it in different ways. Maybe here you directly would have multiplied by 4. Here you would have directly multiplied by 5, found the answer. Or maybe you directly multiply by 4 multiplied by 30, 2 multiply by 30, then you get the final answer. Even that is correct. I did it step by step, one by one, step by step I did. Now some students will ask me, sir, can't we do like this? 100 watt, 60 watt. I add that. 160 watt. 3 hours, 4 hours. I add that. 7 hours. And then directly find the answer. No, Lamai. You can't do that. Can you add the power of this bulb and power of this bulb? Can you add the powers? No, I told you power is a property of that appliance. You can't add the property of the appliance and multiply it by the times. That's totally wrong. This one's property is 100 watt. That's working separately for 3 hours. This one's property is 60 watt. That is working for 4 hours. Separate calculation. You can't add two separate properties together. You can't do that. This is the property of that bulb. This is the property of the bulb. The properties you can't add. And you can't tell the total is this. Now, you have a certain characteristics. Your friend will have a certain characteristic. Can we add and tell a total characteristic? Now, let's say you are good in maths. Your friend is good in science. Can I add and tell? Good in science and maths. Can I tell like that? No, properties cannot be added. Properties has to be treated separately. So this one's property is 100 watt, this one's property is 60 watt. You can't add it. You separately treat it and find the final answer. Energy you can add. Energy is what they consume. What they consume you can add. How much of water you drink, how much of water your friend drinks. That one you can add. That is something you consume. The water you drink, let's say 2 liter, your friend, let's say 3 liter, both of you are drinking 5 liter. That you can tell. What you consume can be added, not your properties. Keep that in mind. So keep it bigger. Any doubts after what we did?
No, sir.
No, sir.
All clear.
Excuse me, sir.
क्या बता?
Sir, why 30 days in some months there are 31 days too? Why is it specifically 30 days?
In maths, if they talk about 1 month, how many days you take? Maths questions. 1 month is taken as how many days? 30 days. Neither. So in science also 1 month we take it as 30 days and do the question.
Okay.
Okay.
So can you show the final answer for the second one?
Like 0.9 kilowatt hour.
Okay, sir.
Okay. These types of questions you can expect in essay question. Can't we multiply the 100-watt bulb with 4? That you can do. You can multiply that 100 by 4 and find the final answer.
So in the essay type questions, will they give mark for the workings?
Yeah, working is a must. Okay, no? That's the plan for today. All of you understood until what I did?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Yes, understood.
So I have a doubt.
Okay, no? Hari, October is going to start. October, there's a extra plan coming up in October. I'll post about it in the group. Extra plan. Yeah, I'll post about it in the group. Right. There'll be a free session coming up. I'll post about it in the group. That is one thing. That's it for today then. Hari. Ehenang, happy Children's Day.
Thank
Enjoy
you,
the
sir.
day.
Thank you, sir.
Thank you, sir. God bless.
Thank you, sir.
Thank you, sir.
I'll say good night.
Thank
Thank
you,
you,
sir.
sir.
Bye, sir.
Good night, sir. Bye.
Sir, good night.
Good night, sir. Bye.
Bye bye, sir.
Enjoy the day.
Bye, sir.
Thank you, sir.
Enjoy the day.
Thank you.
Plus work as well. Right?
Thank you.
Thank you.
Just enjoy the day.
So can you
Enjoy.
give me your personal number?
Not my personal number. The number that I handle the calls, it's there. You can find it in the group. Harined, Ehinang, with that, I'll stop for today. Keep working. I'll meet you all with the day 2 session, which is on next Tuesday. Day 2, the remaining part. Calculations are done. Remaining part will be. Okay.
Thank you, sir. Good night, sir. Have a good sleep.
Night. Good night.